Welcome to the Term 1 Math Exam Review. I hope you find this video useful. Make sure that you look at what I am doing, you follow the steps, and then you also attempt most of the questions on your own. You are welcome to forward any question you may have so that you may get help or assistance before you write your exams. So the first one is about subtracting polynomials, but in some cases, as we see with some of the questions, we may be required to add the polynomials. So the first step when it comes to solving, I'm going to do number 15 and number 17. So let's look at what we're supposed to do there. So don't forget your equals to sign, because now you're starting with solving. So you will have equals to 2x plus 3y plus 3y plus 4x plus 9y. Okay, then the next step will be for me to look into my like terms, which in this case my like terms will be 2x and 4x. So 2x and 4x, and then 3y and 9y. So when I group them, I will have 2x plus 4x, which will give me 6x plus, and then the blue ones plus, the blue ones 3y plus 9y will now give me 12y. That would be my final answer. Let us look at the number 17 that we have here. So here we do the same thing that we did. So we have 5a plus 9b. Now I have to multiply everything in brackets with the negative or the minus that is outside the bracket. So I will have minus 2a minus 4b, okay, because negative times positive gives you negative. Then I will again group my like terms. So my like terms are 5a and 2a, and then I also have 9b and minus 4b. So 5a minus 2a will give me, sorry, let's use black. So they will give me positive 3a, and then 9b minus 4b will be plus 5b. And that will be my final answer. So let's look at the next problem. So we have a question that asks us to calculate the product. So now we have to multiply the two monomials to get the product of that problem that we're solving. With number 1, what you will do, so with number 1, you always need to remember what you were taught in terms of distributing, okay? So we're going to use the distributive property. So you need to multiply 3x by everything in the second bracket, and then when you're done, you will then multiply 5 by everything in the second bracket. So you'll have 5 multiplied by 3x. Okay, so let me just use a different thingy there just so that I can show you. Excuse me. So we will then have 5 multiplied by c, and then 5 multiplied by 3. So this is how we then get to the answer. 3c multiplied by c will give you 3c squared. Okay, c to the power 2, and then 3c multiplied by positive 3 will give you plus 9c. So it will give you plus 9c, and then negative 5 multiplied by c will give you minus 5c, and then negative 5 multiplied by positive 3 will give you negative 15. Then we're going to look at whether or not we have our like terms so that we can simplify what we have. So 3c squared matches with nothing else here, so I will write it as it is, 3c squared, c to the power 2. And then we have like terms there, we have c and c, so 9c minus 5c will give me positive 4c minus 15, because that's the only constant we have. Okay, so you do the same thing to number 2. This is what you will get. So you will get 2g squared, because you will multiply g by 2g to get that, and then you multiply g again by 5g. You will then get minus, okay, so you will get minus 5g, okay, and then you will now go to 10 multiplied by 2g, which will give you positive 20g, and then 10 multiplied by negative 5 will give you negative 50, or 50. So we can simplify further by looking for our like terms. So 2g squared matches with nothing. I will write it as it is. And then minus 5 plus 2 will give me negative 3g. And then minus 50, I will write it as it is because it matches with nothing there. Let's continue. So I just wanted to cover one example from this part of your question or your revision pack, so that you can remember how you're supposed to then distribute when you are given something like that. So let's look at number 18, for example. So with this, you need to remember that you must distribute, okay, by multiplying everything in the first bracket by what's inside the second bracket. So I will multiply by 2y 3 times, and then from there I will do the same thing to negative 11 by multiplying it with everything that's inside the second bracket. Okay, so you need to remember that. So let's solve this. So you firstly multiply 2y by y squared, so you will get 2y to the power 3, which is y cubed. So let's write it a bit up, y cubed, and then 2y multiplied by negative 3y will then give you negative 6y to the power 2, and then 2y multiplied by 2 will give you plus 4y. Then we are done. We go for 11. 11 multiplied by y, negative 11 multiplied by y squared gives you minus 11y squared, okay? So this is y, and then negative 11 multiplied by negative 3y gives you positive, because negative times negative gives you positive 11y. This is long, so I'm going to extend to the second box there. So negative 11 multiplied by 2 will give me negative, because negative times positive just stays as negative. So negative 22 as the last thing. Then I'm going to look for my like terms. 2y cubed matches with nothing there in the line, so I will write it as it is, 2y cubed. So let me just make that look like y and not g. Okay, so 2y cubed y to the power 3, and then we have negative 6y squared and negative 11y squared. So those we can add them and keep their sign, which is minus, and then so 6 plus 11 gives you negative 17y squared. And then I also have another pair of like terms, so I have positive y and positive y and positive 11. Okay, so positive y, 4y and positive 11y, they will then give me positive, so plus 15y and then minus 22. Okay, so let's look at this question. So 2y multiplied by y squared will give me 2y to the power 3, and then 2y multiplied by negative 3y will then give me negative 6y squared, and then 2y multiplied by positive 2 will give me plus 4y. I'm done now with multiplying everything by 2y. I'm now going to multiply by negative 11. Negative 11 multiplied by y squared gives you negative 11y squared. So, and then negative 11 multiplied by negative 3y will then give you positive, because negative times negative gives you positive. So positive 33y. I'm going to extend to the second block there because I've run out of space. So negative 11 multiplied by 2, finally we have minus, because negative times positive gives you negative, so minus 22. And then we simplify, looking for our like terms. So 2y cubed has no like term, so I'm going to write it as it is, y to the power 3 minus. So I have here, so I have 6y squared. Okay, let me just change that line and use a red one. So 6y squared and 11y squared. Okay, so you use your calculator to add those two together. They will give you negative 17y to the power 2, or y squared. And then you have positive 4y and positive 3y. They are both going to give you positive 37y. So positive 37y, and then finally minus 22, because it has no matching term. And that's how you distribute in such a question. Let's move on to the next one. So now we have a real life question there, where we are supposed to use the methods that we just used in solving problems in the previous question, just to show that we have an understanding of how to apply math in real life. So the question says, the dimensions of a playground are represented by a width of 9x plus 1 feet and a length of 5x minus 2 feet. Write an expression that represents the area of the playground. So there they just want, so they just want an expression. So we know that a playground is most likely to be a rectangle, and the area of a rectangle is equals to length. Okay, so that's L, length. Let me just write it in a way that you will understand that that's an L. So length times breadth. Okay, so we can go on ahead and substitute our length, which is 9x plus 1, close bracket, and then we open bracket, multiply by 5x minus 2, then close bracket again. So now here you need to simplify further. So you're going to use the distributive property and multiply what's in the first bracket by the second bracket. So 9x multiplied by 5x, you use your calculator, you will get 45. You will get 45x squared. So 45x squared, and then you have 9x multiplied by negative 2, positive times negative gives you negative, then 18x, and then we are done. So now we can multiply everything by 1. So 1 multiplied by 5x gives you plus 5x, and then 1 multiplied by negative 2, positive and negative, they give you negative, so you have negative 2, and then you can group your like terms to simplify. So 45 has no like term, I'm gonna write it as it is, but I have negative 18x here and 5x, so I'm going to then simplify there. So let's start first by writing 45x to the power 2 so x to the power 2, and then minus, because the bigger number 18 has a negative sign there, so minus 13x, and then finally minus 2 because it has no like term, and then that's the expression that they want. Okay, the expression that represents the area of the playground. Let's look at the next real life question. It says, the Loft Theatre has a center seating section with 3C plus 8 rows. So that's the number of rows. So that's the total number of rows here. And 4 plus C seats of rows. So this is the total number of rows in that row that they are referring to. Write an expression for the total number of seats in the center section. So whenever they say total, just remember that they want the sum, and the sum has to do with addition. So I'm going to write my expression there. So open bracket, 3c plus 8, close bracket, plus, not multiply, we are not looking for the product, we are looking for the total, which is the sum. So, and if they say the difference, remember they want you to subtract or to minus. So open bracket again, 4c minus 1, close bracket. Then I can go ahead and simplify. So this I can write them without brackets because I have a positive there, so it won't change anything. Plus 4c minus 1, Then I'm going to group my like terms. So I have 3c, 3c and 4c, they are like terms. And then I have 8 and 1, they are also like terms. So we're gonna have 3c plus 4c, that will give me 7c, and then 8 minus 1, will then give you plus 7. Okay, so that is the final answer. So that arrow there is just to show that I'm done. So that's the final answer that they're looking for. That's the total. Now let's move on to looking at the properties of different shapes that we learned about. So the first one there, we have a question that has to do with, we know that what we see here. So let me just use a red marker to show. So what we see here, this here is a rectangle, okay? So they are telling us that we are given that a rectangle BDHA, okay? So we are given this, that this is a rectangle. So it means that we can apply the properties of a rectangle to solve this problem. So if this is equals to that line there, so that tells us that we're working with an isosceles triangle. When I look at that shape, and angle A will be equals to angle C, okay? So they want us to prove that angle BDH, which is this angle right here. So this angle here, let me just try to, so this angle, we need to prove that is equals to this angle here, okay? So how do we do that? Let's write down what we are given. So whenever you solve a problem when it comes to geometry, you firstly have to write what you are given. So we are given that in rectangle B, D, H, A, okay? Let me just try to erase that because it doesn't look the way I want it to look. So we are given that. So in the first block, you will actually just copy this right here. So you will copy this into this block here. And then your answer will be, your reason will be given. So why are you saying so? It's because we are given. Okay? And then we're gonna move on ahead and look at what we can deduce from that. So this angle, okay, BDH, according to the properties of a rectangle, will be equals to angle A. Why? Because they are opposite angles. So opposite angles of a rectangle. Okay. So opposite angles of a rectangle, we know that they are equal. So that's your reason. You just write angle BDH is equals to angle A because opposite angles of a rectangle are equal. So let me write that reason for you so that you can see it. Angle BDH. Okay. Now we have established that that angle is equals to that angle. The other thing that we know about a rectangle is that the opposite sides are also equal. So I have this side here, BH will be equals to this side here, AB. And if this is equals to that, then it means line AG and line BD are parallel to each other. And if they are parallel to each other, then it means that GD is also equal to AB. So you can go ahead and write the angle HD equals to AB. Why? Properties of a rectangle. Therefore, angle GD will also be equal to angle AB. Why? Because the two lines are parallel to each other. So that will be your answer there. But I'm just going to go and write the steps that matter the most. So if then we have established that this line AB is equals to line GD, then that will also tell us that line GD will now be equals to line HD, okay? So line GD will now be equals to line HD. And if they are equal, we know that this makes this triangle an isosceles triangle. And then it also makes these angles here to be equal to each other, because they are also going to be angles in an isosceles triangle. Remember, we were given that line CA is equals to line CG. So that then means that if this line is equals to this line, then we know that this here, triangle ACG, will be an isosceles triangle. If it's an isosceles triangle, then base angles will be equal. So let me write that. So we're going to write C. Okay, so CG, line CG is equals to line AG Y given again, and if it's given, so we know that angle A, therefore angle A will be equals to angle G, because base angles of an isosceles triangle. So you can write that in full, but because my pen is giving me problems, I'm just going to use a symbol. So of an isosceles triangle. So of an isosceles triangle. So they are equal to each other. And once we have established that AG is equals to angle A is equals to angle G, therefore it means that, so you will write therefore we write it with 3 dots. So therefore angle A will be equals to angle BDH, okay? So why? We just use the substitution property. We just deduce that because we have shown it in our diagram. So you just write substitution property. So you just substitute the values there to show that it's equal if you are given the values. So substitution property. So I'm just gonna write substitution prop, but it means substitution property. With the right pen that you are using, you can be able to write that in the right way. So let's move on to the next question, where we have to continue proving using the properties of the shapes we learned in class. So we're still working with a rectangle. So the question says quadrilateral ABCD is a rectangle. So we are already told we don't need to prove that. If measure of angle ADB is equals to 4x plus 8 degrees, and the measure of angle BDA is equals to 6x plus 12 degrees, find the value of x, okay? So what are we going to do there? What you need to remember is that if this is a rectangle, then it means that all of these angles here, they will be equals to 90 degrees. So angle A, angle D, angle B, angle C, they'll be equals to 90 degrees. That's the property of the rectangle. You don't need to prove that, okay? So what are we going to do then? We are going to then look into what then can we continue then, or what reason can we use next. So I've already highlighted angle A, so I'm going to start with it. Angle A is equals to 90 degree. 90 degree. And then reason will be, so let me just write that degree properly. So it's supposed to be a smaller 0 at the top. So your reason will be angle in a rectangle. Okay, angle in a rectangle. And then next, if then you see here we have what they are asking us to do falls under this triangle here. We have a triangle there. So our triangle will be triangle DAB, or however you choose to name it. So that's our triangle, and we've already established that this is equals to 90 degree. If this is equals to 90 degree, then these two angles here, this angle that we are given and this angle that we are given, are going to add up to 90. So ADB is this angle here. So it's this angle here, and then DBA is this angle here. So let me just use a blue line to show. So there is the angle there. So these two angles, they will add up to 90 degrees too, because angles in a triangle add up to 180. Okay, so let's just show that. So we're going to say angle A plus angle B plus angle D equals to 180 degree. So 180, okay, so that's a 0, 180 degree. And then your reason is angles in a triangle. Okay, so angles in a triangle. Then we substitute what we have. We have 90 degrees for angle A plus angle B is this angle, angle B is this one here. So let's just show that. So angle B is this one here. So we have 6x plus 12, and then plus angle D, which is this one here. So the reason why I'm not putting it in brackets is because nothing will change, but you can do so and then simplify. Our answers should be the same. So 4x plus 8. So then we can add all our numbers together and all our like terms together. So 6x plus 4x gives you 10x, plus you then add 90. Okay, so you use your calculator to add 90 plus 12 plus 8. So 90 plus 12 plus 8 will give you 110. So 110 equals to 180. Equals to 180. Okay, then we're going to subtract 110 on both sides. So this side will be left with 10x equals to, then 180 minus 110 will give you 70, and then you're going to divide both sides by 10. So divide by 10, 10 not 16, divide by 10. Okay, your answer will now be x equals to 7. X equals to 7. So you have found the value of x. If they ask you then to find out what is the measure of each angle, you just go back and substitute. So let's move on to the next question. So this one, okay, it's related to real life, but we still apply the same properties because we can see the shape there is a rectangle. So we are given that the prom committee is decorating the venue of prom and wants to hang lights above the diagonals of the rectangular room. If DH, so where's DH? DH is right there. So DH is this line here, is equals to 44.5 feet, right? And the EF outside here is equals to 39. Okay, so I just want you to see those numbers where they're supposed to go. So let me just write it in a way that you will see. So 39 there, so EF is 39. Okay, so 39 here, and then and angle GHF is 128, so GHF is this one, so it's 128. There it is, this one here. So they want us to find each measure. So DG, because this is a rectangle, DG will be equals to EF. Opposite sides of a rectangle are equal, so this will be equal to that. So DG is now therefore going to be 39. And then we have to find GE. Oh yeah, GE is the diagonal. So we are given that this first diagonal DH is 44.5. What we know is that the diagonals of a rectangle are equal to each other, and also they bisect there. So 44.5 multiplied by 2. So if they bisect each other, it means this side I have 44 I mean. So this side HF will also be 44.5. So that means the total DF will be 44.5 times 2, which gives you 89. Therefore, GE is also 89 because diagonals of a rectangle are equal to each other. Then let's look at the angles there. So we have information that angle GHF is equals to 128. So that means angle DHE will also be equal to angle GHF. Why? Vertically opposite angles. Okay. Then when we have that, we know that they are equal. But we know that all these angles that are going to be at the center here, they must add up to 360, okay, because they form a revolution. So what we then do to find out what the measure of this angle is, so they want this one, EHF, so this one right here. What we're going to do, we're going to take the sum of all of them. So we have 128 degree plus 128 degree plus EHF plus DHG, and these are angles, so we need to show that out there. So we know that all of them, they add up to 360. Okay, so you do this step by step to get that. So this plus that, so 128 times 2, because it's the same measure, 128 times 2 times 2 gives you 256. 256 plus 2 times angle EHF. Why? Because we know that angle EHF and angle DHG will be equal to each other because they are also vertically opposite angles. So that is why we're just saying 2 times. Then equals to 360. And then we're going to subtract both sides by 256. So this side will be left with just 2 times angle EH HF equals to 360 minus 256. When you punch those numbers in a calculator, they give you 104. And therefore, you need to then divide both sides by this 2 here. So let me show it with a blue marker. So this 2 here, you need to divide both sides by it. So this side 2 will cancel, and then that side. So we'll be left with angle EHF equals to 104. Okay, so let me write that properly so that it doesn't look like 164. So 104. So 104 divided by 2 gives you 52. So the answer is 52 degrees, and we said that angle angle HEF will be equal to this angle on the side because of vertically opposite angles of the diagonals there. So angle HEF and then angle EHF, so that's the same angle. So I think they wanted to say DHG, so we're still going to write 52 anyway there. Okay, so angle HEF there. So let's just find it. So we already know the measure of this angle here. Okay, angle EHF, so it's this one here, and we know the side there, and then we also know the side and that side. Okay, so how do we then find this angle here that we are not given? So this will be 90 degrees, and then so what we're going to do, we know that this side here is equal to this side. So EH and HF are equal to each other. So if they are equal to each other, these two opposite angles, angle F and angle E, are going to be the same. So this is 52. So what you have to do to find this here, so let me just solve it here. So to find angle HEF, okay, will be equals to so we have 2, so it will be equals to 180 minus 180 minus 52. Okay, minus 52. So let me just write that in the right way. 180 minus 52 all of it divided by 2, okay? Because this right here would have had 2 times HEF because these two will be equal to each other. So 180 minus 52 divided by 2 gives you 64. And then you have found all those angles there that you're supposed to find in all the sides. So we are still working with properties of shapes, but now we have to look at properties of a rhombus. So we are asked to, we are firstly told that this quadrilateral is a rhombus, so we need to find each value or measure. So if AB is 26, so AB is here, so it's equals to 26, and BD, so BD is this whole length here, so this length here is BD, so it's equals to 20. We need to find AE, so AE is this one here, so let me use a different color for AE. So we need to find AE right here, so AE on the blue line here. So now we are working with this triangle here, so this forms a triangle. And what we know about the diagonals of a rhombus is that they bisect each other. So if this line is bisected, BE is going to be 10 because it's going to be half, okay? So 10. This pendium is Zaida. So it's going to be equals to 10, and then this is also going to be equals to 10. They add up to 20. So the other thing that we know is that the diagonals of a rhombus, they actually bisect each other, okay? And they don't just bisect each other, but they form a 190 degree there. So angle BEA is going to be 90 degrees, okay? Angle BEA is going to be 90 degrees. Your reason will be that diagonals bisect each other. So you will write the reason here, diagonals bisect each other. At a 90 degree, yes. They bisect each other at a 90 degree, or they bisect each other perpendicularly. So you use that. Then if this right here is a right angle triangle, I can use the Pythagorean theorem to find the missing side. So they want us to find what? AE, this one here. So we need to find this one here. We don't know what it is, so we're going to use Pythagorean theorem. So Pythagorean theorem says Mfundo, we are speaking. A squared plus B squared equals to C squared. So I have C squared, Mfundo. C squared is 26 squared. 26 squared equals to A squared will be my adjacent side, okay? So that will be 10 squared. Wherever you put this, it doesn't matter, it doesn't change anything. So 10 squared plus B squared, B to the power 2. So what I'm going to do, I'm going to then, just to avoid stopping and using a calculator, I'm gonna go ahead and simplify the way I know I should. So to the power 2 minus 10 to the power 2. You can firstly solve, write the numbers down, and then subtract both sides by the number from this side. But I'm just going ahead and doing that. It doesn't change anything. So B equals to square root of 26 squared minus 10 squared. So then I'll go to the calculator and then punch the entire number there so that I just get one answer. So my calculator, so you will then say square root of 26 minus square root of 10 squared, which will give you 24. So this side, we now know what it is. It's equals to 24, which makes sense based on what we see there and the numbers that we have. So this is 24. And then they want you to calculate, not to calculate, but to find angle. Let me use maybe yellow. Angle C. So from here to there, angle C, EB. So they want this angle right here. This angle right here, okay? So in order to solve that, so we are looking for this angle here. So this is what they want here. So this angle will be also equal to 90 degrees. So we're gonna say angle CEB equals to 90 degrees. Okay, with the mini zero at the top. So 90 degrees, and your reason will be that diagonals. I hope I can write with this pen, but you know, it doesn't allow me to write well. So I'm going to say the word, you write them in your book, okay? So diagonals bisect each other perpendicularly. So bisect each other perpendicularly. You can write the full word or you can just show like this. So this is to say perpendicular, okay? The other way you can solve this is that because we found out that this angle here, the side, let me use my cursor. So this angle here, the side angle BEA is 90 degrees. So you can then say 180 minus 90 because they are angles on a straight line, and angles on a straight line add up to 180. Okay, so you use the same properties of rhombus to then calculate y in this question. So let's look at what we are given. So we are given that this angle here, angle CDB, so angle CDB, it's CDB, it's this one here. So I'm going to draw an arrow to show you what we are working with. So we are working with this angle here, so CDB, and then we are also given that is 6y, and then we also have angle ACB. So angle ACB is this one here. Angle ACB is this one here, and we are told that this angle is 2y plus 10. So we need to find the value of y. So the first thing that we can see here, because this is a rhombus, okay, we need to look at triangle BCE. Okay, this one here. So let me just use a color to show it. So this one here, this one here, okay, this triangle right here. Okay, we need to look at that because we are given that right there, and then we need to also look at triangle CDB. So we also need to look at this triangle here with red. Let me just, so this one here as well, in order to work out or solve this problem. So that one there, okay? So we need to look at that so that we can see what we can deduce. What we know is that the the diagonals bisect each other, so this side will be equal to this side, and we know that a rhombus is like a square, so all the sides are equal, so this right here will also be equals to this, because we are using properties of a rhombus. And then what we also know is that the diagonals bisect each other perpendicularly, so this angle will be 90 degree, and then that angle that side will also be 90 degree. So these two triangles are similar to each other because side angle. Okay, so I'm going to write that triangle B C E is similar, okay, similar to triangle DCE, okay. Why? Because side angle. That's our reason. And then what we do next, if this are equal, then it means we also know that angle, the other thing that we deduced was that angle CBE, so angle CBE will be equals to angle CDE, right? We realized that by using the properties of a rhombus. So you can write the properties of a rhombus, and then so if that is the case, then I can use this right here. I know that if this is equals to that, then this angle here is equals to that. Okay, so this angle D there, angle EDC or CDE will be equal to angle CBE, because these are similar triangles. Similar triangles have the same angles. All the angles are equal to each other. So this will be 6y. And then angle BCA, this one, will be equal to this angle here, angle ECD. It will also be equal to that one because, you know, similar triangles, and similar triangles have equal angles. Therefore, I can then take the measure of this angle here and then add it with the measure of this angle here plus this one. So the first one we have 90 degree plus, so degree there, okay, plus 6y, okay, then plus we have this right here, and we said this will also now be equal to this angle right here, so plus 2y plus 10 equals to 180. Your reason? Angles in a triangle. So angles in a triangle. Then I'm going to group my like terms. So I have 6y plus 2y, they add up to 8y. Okay, 8y. Let me just not make it look like G. So 8y plus 90 plus 10 gives you 100 degree equals to 180. So you minus both sides by 100 degrees. You have 8y equals to 80, and therefore y is equals to, you divide both sides by 8, so divide by 8 there, divide by 8 there, your answer will be equals to 10. So you found the value of y.